This is the brief on reaction-diffusion decay, governing dynamics and parameters. So what we're looking at here is basically the math that tells us how radioactive stuff behaves. You know, how it spreads out, that's the diffusion part, and how fast it disappears, which is the decay. This is absolutely crucial for figuring out its total lifespan and just how far it can actually travel. All right, so there are really three big ideas you need to grasp from all this. Let's get into it. First up, the math actually treats decay as a kind of sink. Think about it. To get the equations to work, you have to model decay as something that's actively removing material from the system. And this whole process, this decay rate, it's all tied back to the material's half-life. You know, the time it takes for half of it to just disappear. Second, you've got two key players controlling everything, diffusivity and the decay rate. And they do totally different things. Diffusivity, that's all about spatial spread. It makes the material spread out and flatten, but, and this is key, it doesn't destroy any of it. The decay rate, on the other hand, is all about the lifespan. It's basically a mass-destroying machine that just makes the whole concentration shrink and vanish over time. And finally, when these two things are in a race, diffusion trying to spread the material and decay trying to wipe it out, decay pretty much always wins. The material just gets destroyed so fast that it vanishes long before it ever gets a chance to spread out very far. So when it comes down to it, it's that decay rate that truly decides how long any radioactive material is going to stick around.